Good morning, grade sevens, and I hope your Ramadan is going well for all of you. And this week we'll be covering Unit 3 review, fractions, decimals, and integers. The first three parts, Sunday, Monday, Tuesday, will mainly be about fractions and decimals, and part 4 and 5 will be about integers. And there will be bell works, three of them, and very important you pay attention to the voiceovers, the videos, because it will help you with the bell work. Unit 3 review, part 1. Fractions and decimals. Converting from common fractions to decimals. A fraction that can be rewritten over a denominator of 10, 100, 1,000, etc. will have a decimal numeral equal to its numerator and a decimal point location based on its place value. So example, 3 over 10, so it's to the 10th, you can directly change it to a decimal, will be 0.3. 29 over 100 will equal 0.29. And now you have a mixed number, 3 and a 7 over 1,000. It will equal 3.007, because seventh will be in the thousandths place. So it's very straightforward conversions whenever you get a fraction over 10, 100, or 1,000. In cases where it is not obvious what the numerator would be, if the denominator were 10, 100, 1,000, etc., a power of 10. So when the denominator is not a power of 10, divide the denominator into the numerator until the quotient either terminates or else a repeating pattern is established. So example 3 over 40, you would do 40 divided by 3. The answer would be 0.075. 1 over 50 would equal 0.02, which you can also do equivalent fraction, and 1 over 50 does equal 2 over 100, which is 0.02. And that's it, both two are terminating. That means the decimal ends. 2 over 3 is going to equal 0.66 repeated. So you see the bar above the 6. That means the 6, as you can keep on dividing from now till ever, and you always get a repeating 6. 1 over 9 equals 0.111 repeated, and we're going to discuss there's certain next part tomorrow. We'll be discussing when the denominator is 9 or 11, and there's some tricks, and we've talked about it in class, and also there's a page in the book that you can look at, and it'll show you some tricks. Summary table. Relationships between fractions and decimals. Converting fractions to decimals, divide denominator into numerator. So denominators as powers of 10, like we just said. So when you have a denominator and it goes, if it can go into 100, you want to convert that denominator to either 10 or 100, to something that's a power of 10. So convert the fraction to an equivalent 1 with a denominator that is a power of 10 before converting to a decimal. So 1 over 2 equals 5 over 10, 0.5. 3 over 4 equals 75 over 100, which equals 0.75. Dividing numerator by denominator. Another way to do it is you just go ahead and you divide the numerator by the denominator. The decimal form of a proper or improper fraction can be calculated by dividing the numerator by the denominator. The result will be a terminating or repeating decimal. 4 over 5, this is an example here. I don't like this example because 4 over 5, you can easily convert it to 8 out of 10, which equals 0.8, and it's terminating. 2 out of 3, 3 doesn't go into 10. You got to go ahead and divide it, and it would be 0.66 repeated. And 8 over 99 would equal 0.080808 repeating. So it's a repeating decimal. Converting fractions and decimals. In the previous section, we converted fractions to decimals using equivalent fractions with denominators that are powers of 10, or else by dividing the denominator into the numerator. So previously, we showed two different ways. Either it's above 100 or 10 or 1,000, and we convert it straight to a decimal, or we went ahead and we divided. So we have 3 over 100 is 0.03, 2 over 5. So what they did here, they multiplied the 2 and the 5 by 2. They got 4 over 10, which equals 0.4, because 2 over 5 is equivalent to 4 over 10. And 3 out of 20, again, they divided here. What I would do is 20 goes into 100 5 times. 3 times 5, 20 times 5 equals 15 over 100, which equals 0.15. We converted terminating decimals to fractions by just reading off the place value. So 0.031 equals 31 over 1,000. 0.17 equals 17 over 100. 2.09 equals 2 and 9 over 100. The only thing here when you're going from a decimal to a fraction is to make sure when you get to the fraction, you make sure you put the fraction in reduced form, or we call it simplest form, not simpler, simplest form. And all of these are already in simplest form, so there's no need to break them down any further. Now some questions. Write each of the following common fractions as decimals. 3 out of 10 would equal 0.3. Very straightforward. 9 out of 100 equals 0.09. 19 over 1,000 is not equal to 0.19. It's equal to 0.019. If you notice, it goes to the thousands place with the 3 past the decimal. 103 over 1,000 equals 0.103. Now, 12 over 20. There's two ways. I can go down, divide by 2, or multiply by 5. I decide to divide by 2. So 12 divided by 2 is 6. 20 divided by 2 is 10. You notice 10 is the denominator, 6 over 10. The answer is 0.6. 12 over 20 equals 0.6. 1/2, same thing as 50 over 100 or 5 over 10. The answer is 1/2 equals 0.5. Show each mixed number as a decimal. 3 and 9 over 100 equals 3.09. 6 and 7 over 1,000 equals 6.007. And 7 and 1 over 25 does not equal 7.1, because a lot of students will do that. A lot of students will say equals 7.125. No, 1 over 25 does go into 100. Multiply each one by 4, so you get 4 over 100. So then it equals 7 and 4 over 100. So the answer would be 7.04. So 7 and 1 over 25 equals 7.04. Write each of the following fractions or mixed numbers as decimals. Continuing, 7 over 100 equals 0.07. 11 over 50 does not equal 0.11. It is not over 100. Equals 0.22, because times both of them by 2 equals 22 over 100. The answer is 0.22. C, 11 over 1,000, there's no converting here. It would equal 0.011. 2.5 is equal to 2.5. As you look back at number 1F above, the one from the one number 1 above, it was half, which equals 0.5. So 2.5 would equal 2.5. And 2 and 1 over 9 equals 2.111 repeated. F, 1 and 3 over 11 equals 1.27 repeated. And the last two, E and F, I will explain further in the next part, tomorrow's lesson, and also guide you to a page in their book that also explains this even more. And we talked about that in great depth in class. There's a trick whenever the numerator is 9 or 11. Is very simple to figure out what they're going to be repeating decimals, but what they are will be very simple. And I'll leave you with number 1 and 2 on these slides to work them out. And again, if you cannot convert it, the numerator into 100, you go ahead and you divide, or you look for tricks. Example, I'll do number 1, G is 6 over 11 is going to equal 0.5454 repeated. So whenever the numerator is 11, you multiply the denominator by 9, and that will be the repeating numbers in the decimal. Good luck.